A very warm welcome to all of you. Myself Rajan Choudhary, Professor in the Department of Civil Engineering, Indian Institute of Technology, Guwahati, instructor for the course NPTEL MOOC course Pavement Construction and Technology, funded by Ministry of Education, Government of India. Today's talk will be the continuation talk for our topic Subgrade course and its functions under the module 2. Now, in the very beginning, I would like to acknowledge the use of text, information, graphs and images sourced from various textbooks, codal standards, journal articles, reports, newsletters and public domains. So, this is the continuation of our discussion over the key features, rows, functions, compositions of our subgrade layer of a flexible pavement. Now, if one wants to know what are the most desirable characteristics which you want from a subgrade layer. So, one is the very first thing which comes into mind is it should be able to take load, good amount of load. So, I can say adequate load bearing capacity is my one important requirement for any this kind of a structure. So, this is one basic requirement. If I construct any flexible pavement structure, this is my bottommost layer, or I'll say this is my foundation which I'll create. All these layers over above for the construction of this structure will come over this my prepared subgrade. So, I want it to have adequate load bearing capacity. What it means adequate, how much do you require? This is when you design a flexible pavement structure, a small part of it will cover in the later slides. But here we can see, yes, I want a layer which have good load bearing capacity. Other part is, as I said, on the top will have the camber to remove out any rainwater which falls over the road surface. Also, we will have side drains also. Inside this also, later on I will tell you when we will be discussing about these granular courses that we have a provision for a drainage layer. So, that any water which because of one or the other reason enters into a pavement structure is allowed to move out as quickly as possible. So, even with that particular case, we always prefer that whatever our subgrade is, it should have a good drainage characteristics also. That means it should not hold water. So, if by mistake some water enters into it, the water should be able to drain out of this particular layer. So, it should have it should not have a water holding nature. Like clay, if clay soil is there, it will hold the water. That is not good for. So, I will not prefer that kind of characteristics for my subgrade. If it has a water holding nature, then it will lead to a reduction in the strength. Uniformity and stability, whatever material I am going to use should give me a uniform characteristics throughout the length and the width and the depth. So, because I'll construct a subgrade of a thickness of around at least 50 centimeter. So, in that case I want, and it may be constructed in 2 layers or maybe more than 2 layers, 3 layers also. So, I want that the characteristics are uniform in the depth of this particular one, the soil characteristics are uniform. It is not, some variation will be always allowed, but significant variation should not happen, otherwise it will hamper the stability or it will make our analysis difficult. Resistance to volume changes, especially that happens with the addition or with the removal of the water. As I said, if water enters into it, it has a water holding capacity. If the layer becomes saturated, then that particular one results into a challenge with respect to the strength, because when it is in a waterlogged area, it gets saturated, pore water pressure increases, that reduces the shear strength of the soil. So, all these leads to ultimately reduction in the load carrying capacity. So, I do not want a material which have, and this water holding capacity I can measure in terms of the especially in terms of the volume changes. We do certain tests, swelling index is measured. You might have in some other course of soil engineering, you might have encountered with a term which is swelling index or plasticity index, which gives you an idea about it, water holding capacity of a soil. So, with that water holding, when the water moves out, when the water comes, how the volume of the because if there is some volume change in this subgrade layer, that will affect the ore. If there is some swelling, it will uplift, it will try to put a upward pressure and try to lift the above layers which is there over the subgrade. So, that kind of characteristics is not desired from a subgrade. Now, why all these different kind of characteristics are required? So that it can serve certain purpose. Now, what is that purpose is specifically important for us to understand why we do require a good drainage, why do we require a good strength, and why do we require that it should be uniform, it should not go much volume expansion, because there are certain functions which are required in it. Along with it, we will discuss about the functions in the next slide. So, along with it, another important characteristics is whatever material you are going to use in the subgrade construction should be easily compacted in the field, because finally you have certain standard rolling methods, rolling equipments which are used for compacting different layers, subgrade layer, granular courses, or your asphalt courses, that is bituminous bounded courses. Ease of compaction, that is one, because you need to achieve a given density. Density will help you to get a good strength also in terms of different parameters. So, whatever material you are using should be you should be able to compact it also in the field with the standard compaction equipments. And the flexible pavement design codal guidelines, which is for IRC 37, it says that the subgrade course should be well compacted to a minimum of 97% of the density which is achieved in the lab. Now, lab, when you do a laboratory evaluation of any soil, so as to figure out the parameters in terms of its density, we call them as maximum dry density or optimum moisture content, or the strength in terms of California bearing ratio. So, it says whatever maximum density which is achievable in the lab, 97% of it should be achieved there in the field also. And this is a specific requirement for important roads which are your national highways, expressways, state highways, and heavily trafficked load, so as to limit rutting caused by additional densification of the layer. This what is rutting, how it looks like, why it happens, that we will discuss again in today's this lecture itself. So, I want a material, I want to select a material. This is a subgrade layer which is getting, has been laid, and you can see the compaction is going on. So, it should be easily compacted. It should not happen that I am putting n number of passes, still I am not able to achieve the density. So, it should be easily compactable also with the standard compaction measures which we have or equipments which we have in the field. Now, as I said, all these characteristics, if they are present, then it is able to serve the purpose for which it is constructed. Now, what is the purpose or what is the function it has in the flexible pavement structure? The first is, as I said, all the layers. Here you can see this is again a cross section. You can see this is a cross section which is made for a flexible pavement, where this is the bottommost, this is your subgrade, then you have your sub-base courses, granular courses, you have your base courses, and on the top the bituminous bound courses or the wearing courses have been shown, and there comes your wheel load. Now, when the wheel load comes, the load stresses gets distributed over a wider area. Now, this distribution depends upon the thickness of the individual layer and individual layer strength characteristics. Finally, some stresses will come over a wider area over your subgrade. So, your subgrade should be able to bear the stresses which, because of the wheel load, comes to the subgrade. So, it is said that one important function is to receive the load stresses from the upper layers without getting overstressed or distressed, because if it get distressed, that is deformed because of these wheel load stresses, then the layers which are over above this particular subgrade will also get affected out of it. So, it should be able, so if I give a composition and I give the wheel load, I should be able to see what stresses comes up at this particular level and whether my material is good enough to bear those load stresses. So, my function is whatever finally the stresses which comes over this structure which I have constructed, which is my pavement crust, should be my subgrade should be able to bear those ones. So, this is one function. Now, bear, because why it has to bear? Because this is the foundation, this is our foundation, because this provides the adequate base, support or foundation for placement of all the above layers. Even it is very important when I am constructing the first layer, I am constructing the subgrade. It may be, as I said, subgrade may be the thickness of the subgrade, which say in course 50 centimeter. So, I can do some construction in terms of say 20 centimeter followed by 2 layers on the top. So, 15, 20 centimeter, 15 centimeter and 15 centimeter, 3 layers I have constructed. So, if I do a construction in this particular manner, you can see this is a construction which is going on subgrade. They will be laying, watering and compacting. This we will discuss later when we will discuss the subgrade construction. Here the purpose is, during construction itself, it may get distressed, or if I constructed subgrade and then when I started with the construction of the subbase layers, because of the subbase, the dumpers which are going to bring it, because of the material, because of the compaction of the granular courses, it may get distressed by the construction vehicle loads also. So, I need to have a good foundation support. Finally, because this is only a bare minimum, we will have a very high amount of traffic which will come up over this particular surface in a service life which may be from 20 to 30 years. We know conventionally we design flexible pavements for a life of around 20 years. So, then you can see how many repetitions of different type of vehicle loads will come up. So, this should provide a good foundation so that we can have the placement and compaction of the upper layers as well as whatever load stresses which are going to come over this particular one, it should not get deformed. So, these are the two functions, important functions which is related to load. Other function, it says if some water enters, I have given a camber on the slope, I have given side drains here in this particular one. But then also there are chances, why chances? In that case I will say, if I'll have some paved shoulders or I'll have some earthen shoulders which are having a camber or a slope which is more than my wearing course. So, I have this one now, and then I'll have my trenches here. So, there are chances if I don't construct good earthen shoulders, the water may come down and it may reach to the level of the subgrade. So, as I mentioned, when I'll have these granular courses, I'll create a particular layer especially for the drainage purpose. But in some cases, if that has not been constructed, or if it is constructed then also not in a proper manner, so it's not serving the purpose, but then your subgrade itself should serve the function that it should be able to move out the water out of it. Whatever there may be at a later stage, some cracks may develop on the surface, water may enter from those cracks, may go down to the underlying layers when it reaches to the subgrade. So, then in that case subgrade should not hold the water there itself. So, I will prefer that the function for which subgrade is not basically meant for, but still if it has some amount of capability to allow removal or drainage of any water which has entered or reached to the subgrade course, I will be very happy. If my material is like this way, so it can allow some removal of the water which has entered, which is not through any means. If it moves out of it, my pavement structure, I will be very happy. So, this can be one function which it can serve. And finally, because I constructed subgrade to a particular thickness only. Now, this ultimately my subgrade is resting over the natural ground. So, finally, and this natural ground, or it may be a good amount of thickness, because with embankment I may have to raise the level to, say, yesterday in last lecture we discussed that you can have embankments of height more than 6 meter, and there is a particular standard which is to be referred for the construction of embankments for height 6 meter and more. So, if there may be an embankment also, so whatever loads finally comes to the embankment also, it should be within the I should say the allowable capacity or bearing capacity or load carrying capacity of the embankment. So, it says transmit pavement loads to the underlying layers for effective load dispersion. Effective means there should be no deformation happening in the embankment also. So, this is what my main functions. I will say it should give us a good foundation, it should be able to bear the loads which will be there during the construction, it will the loads which will come during the service life. So, it should serve a good foundation for those pavement crust layers, it should serve a good foundation to take up the load stresses which are going to come during the design life. If some water enters, if it serves the purpose of removal, very good in that case, and it should be good enough if there are high embankments, then the load which reaches to the embankment also should be allowable within the within the capacity of that embankment layer strength. So, these are some typical functions of a subgrade course. Now, I keep on I have talked that subgrade may get deformed. So, how the subgrade get deforms, and because once I have constructed my pavement course, I doesn't know, I doesn't get an idea whether my subgrade is getting deformed or not, and if it is getting deformed, what it means? It means there is some plastic movement is there. We call as one common term which is used, which will be referred here, is subgrade rutting. So, you can see from this top, this is a top surface, you can see a bituminous surface where there, but here along the wheel paths you see some depressions are there, especially when vehicles, and these depressions are usually found along the wheel paths. Within the lanes, vehicles try to follow particular path, and you will find maximum amount of distresses. Distress means anything which may be in terms of some loss of material, in terms of some cracks, in terms of some depressions, so or movement of some material. So, here you can see there is a depression which is created with respect to the main surface of the carriageway. So, this depression, subgrade deformation can be one reason behind it, if this kind of deformation. So, the subgrade deformation can get reflected in this particular manner on the top of this road surface. So, it says that loads are distributed through the pavement structure. We have seen it is go down, it gets distributed over a wider area and pushed down on the subgrade. Finally, it comes to the subgrade, because that is your foundation layer. Like we have a foundation for any building, that subgrade is the foundation for a pavement. It is, if it is not strong enough, it gets deformed, especially along the wheel paths, because maximum stresses, wheels will keep on coming over that particular, especially channelized movement is there. So, this is known as subgrade rutting or a plastic deformation. This kind of deformation is there. Subgrade rutting or structural rutting, and this we call as a structure failure. There can be a certain failure which can be in terms of, I can say some functional related distress has occurred. Functional, especially if I will find that initially whenever a new surface is created, some amount of texture is there on the surface. But if that and that texture helps me to give the frictional resistance. In due course of time, with the movement of traffic, the texture gets reduced. You might visualize it more from the terms of airfield pavements, where whenever there is a landing of an aircraft is there on airfield pavements, you need a good friction from the surface. Now, these high speed at very high load stresses when it comes over the surface, so the surface gets polished. If it gets polished, the frictional resistance gets reduced, so chances of skidding increases. So, that is why if there is that loss of texture is there or loss of frictional resistance is there, I can call it as a functional reduction, a reduction in the functional performance. But when this kind of failure, deformation occurs in the subgrade, then it is a structural deformation. So, here I will say this subgrade rutting is my structural rutting, are mainly in the form of wheel part depressions in the subgrade course under traffic loading. So, this is what the pavement settles into these subgrade ruts, and since layers are resting over each other, in due course of some time, if there is a deformation in the subgrade, then the upper layers will also get in due course of time depressed, and this will get reflected on the top surface. So, this is a picture to get a more understanding of it. Our concentration or our focus will be on subgrade rutting. The other kind of ruttings we will discuss when the other courses will be discussed. Now, here you can see if there is a subgrade and the subgrade is weak enough, when the load stresses comes over the subgrade surface, it gets deformed. It gets deformed, there is a depression which is created, and this depression mainly maximum chances are it happens under the wheel path. So, when it happens, it gets deformed, the upper layer also gets deformed, and this is the manner this deformation gets reflected on the top. So, so it may take some time, but by the time internally there is a big structure failure which has occurred when it comes on the top surface. Now, what do we do? How do we take care of this particular, especially to ensure that the subgrade doesn't get deformed more when these traffic loads are coming over it? So, IRC 37 the guidelines which we use gives us measures to control this rutting at the level of the subgrade. Now, if this is the concept behind the flexible pavement design. The approach we follow is a mechanistical empirical approach we follow there, and what we consider there, we consider these whatever layers we construct, we consider them as an elastic layer system. So, we have a subgrade which is a semi-infinite layer. We have the layers which I can divide into two major groups. One can be my granular layers, second can be my bounded layers, bituminous layers. So, my focus is main on construction aspect, but I will just give you a glimpse how these things are taken care from the design aspect also. Now, see, a vehicle load is coming on the top of it. We design it considering a standard axle load, and a standard axle load is taken as 80 kN. Now, when this 80 kN, which is in the form of a dual wheel assembly, so this will be an axle, there will be two wheels on the other end also. So, I can say on one single wheel a 20 kN load may come up, contact area will be there, all those things will be there. These are more in discussions of a course related to pavement analysis and design, but I will just give a glimpse how subgrade is taken care to avoid these kind of deformations. So, when this loads will come up on my structure, I will look for some mechanistic parameters. What are those mechanistic parameters? I will see how much amount of strain is there or stress is there at the bottom of my bounded layers, how much amount of strain is there on the top of my subgrade, how much amount of strain is there just on the top of my bituminous courses. These are some critical mechanistic parameters which are to be considered. Now, for subgrade part, I need to know the vertical strain which is going to come over the subgrade. So, we follow the mechanistic approach to compute the in this elastic layer system how much vertical strain is going to come here, and then we look into certain models to compute that this amount of this amount of vertical strain with number of repetitions can cause how much of rutting. So, that's the empirical model. So, that is why we call as mechanistical empirical approach which we use in the design of our flexible pavements. So, what it says, the vertical compressive strain on the top of the subgrade is considered as the critical mechanistic parameter for controlling subgrade. Less strain, definitely the chances of rutting are less. So, this is less number of repetitions, again the chances are how less strain can come up. I will build up good thickness of these layers, less strain will come up. If load is less, then also less strain will come up. If the quality of these materials are better or they are more stronger, then also less strain will come up here in this case. So, this is how for different combinations I can look for lower strains at the subgrade, and my subgrade also have certain strength, so it can take up strains to a certain extent also. So, for the satisfactory performance of the flexible payments and to ensure that the magnitudes of distresses are within acceptable levels during the service life, the guidelines recommends that the payment sections be selected in such a way that they satisfy the limiting stresses and strains which are prescribed by the performance models. As I said, now subgrade deforms mainly in terms of plastic deformation. So, the rutting is there. So, I'll look for models which predict with that particular strain and a design load how much amount of rutting can be there. That is the second aspect. So, for that again IRC 37 have given models for us. With the use of those models, we can estimate the amount of the load or the number of repetitions of design design load it can take before an acceptable limit of rutting happens. So, it says if the rutting on the surface is 20 mm, I will call it as a field section. So, my maximum I will consider that the structure failure will be there if 20 mm of rutting is there. So, I will look for how much amount of, if with a particular vehicle load a particular amount of strain is there on the top of the subgrade, then how many number of repetitions of that kind of standard vehicle it can take before the 20 mm of rutting takes place on the top of the surface. So, this is what is there. So, it says the equivalent what we get from these models are given. These are especially the rutting models with respect to the subgrade rutting. It says the equivalent what we get, what is the NR out of it. So, it says the equivalent number of standard axle load, because these are the we compute design traffic in terms of standard axle loads. Repetitions that can be, because we have different types of vehicles with different axle configurations. So, we cannot design vehicle for all type of vehicles, we have to first convert them to certain standard axle and then we design our payment structures. So, can be served. So, I'll try to look for equivalent number of standard axles that can be served by the payment before the critical average rut depth of 20 mm or more occurs and that is given by these two equations. And what these two equations have, there is one parameter, this is EV epsilon V which is there, NR which is there. What NR says, it is the subgrade rutting life, that is the cumulative equivalent number of 80 kN standard axle loads that can be served by this particular payment before the critical rut depth of 20 mm or more occurs. So, it can take till 20 mm of rut depth occurs, it can take this many number of repetitions of the design load. And what epsilon V, it says vertical compressive strain at the top of the subgrade. This is the mechanistic parameter calculated using linear elastic layered theory by applying the standard axle load at the surface of the selected payment system. So, this is what is required, and then there are two equations, one is for 80% reliability and second is for 90% reliability. So, to have a more accurate determination of this life for subgrade rutting, especially this 90% reliability is more important when we are looking for important roads, especially expressways, national highways, state highways or urban roads, and even in case the design traffic is more than 20 MSA, then also you will use this 90% reliability equation. So, this from the flexible payment design aspect also gives the control that the composition of your payment is in such a manner, considering your strength of subgrade, considering the strength and thickness of your granular courses, considering the strength and thickness of your bound courses and the amount of traffic which comes over it, that if I'm having a design traffic, say a value of my design traffic may be 100 MSA. So, that is there in a period of, say I have designed a road for 20 years of life. So, if I look from this aspect, then this NR value should be more than this 100 MSA. So, I should get, so that this structure will not fail because of subgrade rutting, this NR value may be say 110 MSA. So, it should be, important part is it should be greater than 100 MSA. That means yes, for your design traffic, this subgrade is not going to fail in terms of your rutting criteria or the deformation, plastic deformation, which is. So, this part is to be taken care while you are constructing. So, that is why it is very, very important to ensure the correct strength and to achieve that strength, because you do some laboratory determinations of density in the laboratory, and as mentioned, 97% of it has to be achieved in the field also. Now, these characteristics of individual the materials which we use in subgrade construction depends upon various internal factors. One is soil type, as say broad categories, a granular is one, is clay is there, or silty soil is there. So, different classification systems we have. I will not go into the detail of it. What moisture content is there. So, Atterberg limits is there, the inherent soil moisture content is there, density, what density you can achieve with that particular soil. This is also an inherent characteristics which will help you to get an idea about the strength which you can achieve by that kind of material. Internal structure of the soil, grain size distribution, texture of the soil, that will play, and what kind of loading comes over it, because we have a moving load which comes over it. So, there may be certain cases where only static loads get applied, but in case of pavement structures you have moving loads, which is so, and if traffic is more, you get a less of rest period. If and in certain cases where high speed corridors are there, or you do not have heavy traffic, the vehicles pass at a high speed compared to intersections, and where slow moving traffic is there, the load applications may be for a longer period of time with lesser amount of rest period. So, all these are important to, so whenever you need to determine the soil strength, certain characteristics are to be known to us, and then you figure out some parameter in the laboratory to determine its strength. If that is not done, we can very well see the kind of failures which can occur in this particular. Now, when we are making selection of some materials, there are some basic guidelines which are also given there. So, it says this particular, this is IRC 36 which we have, which gives us recommended practice for construction of earth embankments and subgrades for road works. So, this gives you an idea. Now, what it states, I have picked up some important tables out of it. Only the materials satisfying the compaction and density requirements shall be employed for the construction of embankment and subgrade. We have discussed what is embankment. So, what it says, like say, it says that if you want to use a material for subgrade and earthen shoulders, it should relative compaction and what density it should be achieved there, it should be at least 97% of what the laboratory density which you determined with the help of 2720, and that is 2720, and then whether it was a heavy compaction or a light compaction, depending upon for which category of or which level of traffic you are considering. Embankment, again it says you can go up to 95% of the laboratory density. When you are using expensive clays, it says expensive clays, they should not be allowed for your construction especially. It says expensive clays should not be allowed for your subgrade materials, especially for subgrade. It should not be allowed for subgrade construction, and we use subgrade in construction of earthen shoulders also. So, it should neither be allowed in the subgrade course, it should be neither allowed in your earthen shoulders construction. Embankment, yes, you can go, it mentions, but precautions have to be taken, allowed after suitable treatment, that is the stabilization you can do for expensive clay soils. Again, in terms of density, as I mentioned, the density can be one parameter. So, in terms of density, some requirements are given. It says that for national highways, state highways, major district roads, maximum laboratory density unit weight when tested as per IS 2720 part 8, it says the embankments up to a height of 3 meter and not subjected to extensive flooding can have a density which should not be less than 15.2 kilonewton per cubic meter. So that means 1.5 gram per cc. So this is a specific requirement, and if I am constructing embankments which are exceeding 3 meter of height, then this density of the soil which is achieved in the lab should not be less than 16 kilonewton per cubic meter. If I am using a soil for a subgrade, and here see earthen shoulders, the unfortunate part is many a times we because of some lack of knowledge, information or control, whatever it may be, we miss to use good quality of soil in earthen shoulders. And even if we don't have a good control, we can miss to have it in shoulders in subgrades also. It says that the density should not be less than 17.5 kilonewton per cubic meter. And when it comes to rural roads, definitely the requirements are a bit relaxed. Here you can see compared to what you have for the state highways, national highways and major district roads and expressways. So this is an important thing which needs to be taken care when you are selecting any material for subgrade. It is the foundation of your payment structure. One has to be very, very careful out of it. I'll just end up by showing you some pics. Here you can see you can't expect what kind of failures occurs, and there may be a multiple combinations, but yes, I'll show you. You can't think about this left hand side. You can this first pic you can see it's a 4-lane highway. See how the subsidence has taken place. This is the original level, how the surface has gone down. This is again, you can't expect if you don't have a good control on your materials which you are using at the subgrade, the slope which you are using, the compaction which you are doing, the thickness which you are making out from the design, the thickness which you are actually providing on the field, the compaction, 97% of the compaction of the lab has to be achieved. If that is not done, you can have failures which may be very, very challenging or unsafe for the vehicles which are moving on the surface. So there are combination of factors. You can see this is a bituminous bound course, you have the granular courses, on the bottom you have subgrade courses. So you should not feel that okay, payments will not fail in this big manner. You can see only some cracks coming up, some depressions coming up. No, this can be, and when it comes to hilly regions, it even becomes more risky. So subgrade, the foundation of your payment, our payment structure plays a very, very important role. So with this particular one, we'll end this particular talk here. Thank you so much.